Sir, welcome to all. Uh,
சொல்லுங்க சார்.
yes. One second. Sorry for the disturbance. Actually, I am traveling in the bus.
அப்பனா விட்டுலாம் சார். மேரி மேடத்தையே கொடுக்க சொல்லிடலாம். அவங்களே ஒரு செல்ஃப் இன்ட்ரோ கொடுக்க சொல்லலாம். ஓகே.
Dr. Mary, you can start. You can self-introduce yourself, please. Dr. Mary, are you there?
அவங்களோட நெட்டு வந்து கொஞ்சம் சிக்கல் இருக்கு போல இருக்கு. அது சுத்திட்டே இருக்கு. அதனால அவங்க வாய்ஸ் கேட்கல போல இருக்கு.
Dr. Mary joined in TNEB in the year 2014, I think, sir. She was HOD of Hindustan Engineering College then. She did her PhD in solar energy. She presented one paper in San Francisco, sir, IEEE paper. And she was working in Hindustan College.
ரொம்ப சந்தோஷங்க சார்.
But she is very soft spoken. After almost working with her 2 years, I learned this only 2 months back on.
So still we
doesn't reveal her, sir.
Still we do not know, so let her also introduce herself and we can proceed with the classes, sir. Very great. PPT mode வச்சிருங்க மேடம். மேம் நீங்க பேசுறது எதுவுமே கேட்கல.
இப்பதான் அன்மியூட் பண்ணாங்களா?
இல்ல அன்மியூட் பண்ணிட்டாங்க ஏற்கனவே. சோ அவங்க பேச முயற்சித்து இருக்காங்களா என்னன்னு தெரியல. மைக் எனேபிள் ஆகல போல இருக்கு. மேடம் மைக் வந்து நீங்க தனியா வச்சிருக்கீங்களா லேப்டாப் மைக்லயே பேசுறீங்களா?
Hmm. We are able to see your screen, but we are unable to hear your voice.
Good evening, sir.
Good evening.
Sorry for the delay, sir.
No problem. Good evening. Please continue.
Today we'll be dealing with the basic concepts of thermodynamics. So to begin with, let us start with the basic definition of thermodynamics.
Actually, you can put this in PPT mode, ma'am. Maybe you are sharing the regular mode, so the show would be working in the beginning. So you can close the screen and you can share the show mode.
Show mode.
Yes.
Yeah, now it's okay, sir.
No.
ಯಾರ್ದು 5 ಸಬ್ಜೆಕ್ಟ್ ನೋಟ್ಬುಕ್ ಹೌದಾ?
Show mode.
Okay, madam. Maximize it. Maximize it.
No, actually the sharing. You just close the screen, ma'am. So you just sharing. You just disable this sharing, and when you
Full screen la F5 lo போட்டு அதுக்கு அப்புறம் அதை ஷேர் பண்ணுங்க.
The F5.
சரி, ஓகே, நீங்க ப்ரொசீட் பண்ணுங்க மேடம். Good. Now okay, ma'am. Fine.
Okay.
Yeah, I'll continue, sir. So we'll start with the basic definition of thermodynamics. It means heat in motion. So it begins with our day-to-day life.
Your voice is gone, ma'am.
Yeah.
Okay, fine.
So can you, as the next slide is displayed, sir?
Now it's moving. Now
It's moving, ma'am.
This. So this heat transfer is common from, say, from our basic human being to power plant. Every day we perspire and we generate heat. We take in heat as energy form, and this is heat in motion. If we take in a power plant, there are multiple thermal components such as steam turbine, heat exchangers, boiler, etc., where the thermal energy is being transferred and one form of energy is being converted to another form, and it is in motion. So, and it is doing some kind of useful work. So there are two forms in which we can analyze this heat and motion. Next slide.
Third slide.
Third slide.
That side is only visible.
Yeah. There are two approaches. One is the individual molecules. Amount of gas is occupied in a cylinder, in an IC engine. We will be dealing with the net effect of the whole system. What is the effect? Net pressure, temperature, and volume. We will not be dealing with the individual molecules and their effects. And most of our study in the thermodynamics will be of the macroscopic form. Whereas there is another study, which is called to be the statistical thermodynamics or the microscopic level, where the van der Waals forces, the colloidal force, the behavior of all individual particles, that will be studied. And their effects of in their work, everything, the interrelation forces will be studied. So whatever we deal with the energy audit exam will be in the form of macroscopic level. And as we know, the basic terminologies used in thermodynamics, to start with, it is a system, surrounding, boundary, and universe. So system, it is the region where we are going to focus. If you are going to study about the steam turbine, you are going to focus the parameters under study. So that steam turbine is termed to be the thermodynamic system. And whatever has some effect on the steam turbine, which surrounds the steam turbine, it is termed to be the surrounding. And surrounding means it should have some effect on the system. Say, for example, if you have a classroom of n number of students, and it is considered to be the system, the space outside the classroom. Say there is some noise outside the classroom, naturally it will have some impact on the classroom. So that will constitute the surrounding. Similarly, if you take the steam turbine to be the system under study, the space outside, maybe atmospheric, the region outside, that is called to be the surrounding. And we need to separate the system and the surrounding. That is usually by an imaginary layer that you call to be the boundary. And all these combination, we call it to be the universe. And the study of universe with related to entropy forms the third law of thermodynamics. Coming to the property and state of a system. So properties, if you need to describe a system, we need some characters to define it. So in thermodynamic system, there are three basic properties which are normally utilized to define the system. And they are the pressure, volume, and temperature. So PVT, this forms an important significance wherever analysis is there, we will be dealing with these three characteristics. Any plot, any graph to be plotted, we will go for PV plot or VT plot or PT plot. So these are the thermodynamic characteristics of the system. They define the thermodynamic system. Say particularly it is at one point, we need to measure the pressure, volume, and temperature. We cannot measure at random. When we need to measure, the system has to be in thermal equilibrium. I'm sorry, it should be in equilibrium, whatever may be the equilibrium. It may be thermal or mechanical or chemical. So at one condition, we will be measuring the thermodynamic property, and that we call it to be the state of a system. So the thermodynamic systems, if we take in, there are many types. Of course, the three main thing, one will be the closed system, where if you take in a system under study, where only energy transfer is there is no mass transfer. Then you call it to be the closed system. And you separate it by means of imaginary line, that we call it to be the boundary. The other system is the open system, where mass transfer is there, also energy transfer is there. So this is typical example we can take as a steam turbine, where quantum amount of heat energy in the form of steam is entering the steam turbine, and it is leaving as exhaust steam after doing some work. So we cannot go behind the steam and study. So what we do is we control the volume by means of drawing a line that is called to be the control surface, and that volume is termed to be the control volume. The boundary, which is separating the system and the surrounding. In case of open system, it's called to be the control volume. So here, mass transfer will be there, energy transfer also will be there. So this you term to be the open system. And the third variety, we call it to be the isolated system, where there is no energy transfer, nor the mass transfer. Completely the system is isolated from the surroundings. We create such isolated system. There is no isolated system in nature, but we create it. So to be very familiar, we can take the typical example of a hot water getting boiled in an open pan. So here, energy and mass transfer is there. Both are getting exchanged. So this is an open system. If you cover it with a lid and again you heat it, the mass doesn't change, but only energy is exchanged. So it's a closed system. The same hot water, we are going to pour it in a flask and keep it closed. Then you don't have the energy and the mass transfer. So you create an isolated system. The other one, we move to the thermodynamic equilibrium. So equilibrium itself means it's a state of balance. So when a process is being occurring, you cannot go behind and take the characteristics. When you need to measure the characteristics, the property should be in a definite state. So if a system involves thermodynamic characteristics, then you call that system to be a thermodynamic system. So when can such system attain equilibrium? So scientists have analyzed and they have come to a conclusion that a thermodynamic system is said to be in thermodynamic equilibrium if it has three equilibrium attained. One is the thermal equilibrium. That means the temperature of the system should be even throughout the system. And second one is the mechanical equilibrium. Its pressure should be uniform, or there should not be any unbalanced forces involved in it. The third one is the chemical equilibrium, where there will be, the reaction will not be there. The forward will be equivalent to the reverse. So three such equilibrium exist in a thermodynamic system. Then only we say that the system is in thermodynamic equilibrium. And process. So we had initially seen what is a property and how does it relate to the thermodynamic system. So when you define system, say for example, take the same condition of the steam turbine at a particular instant, pressure one and temperature T1. Steam is entering into the steam turbine. You measure the parameters. We say it to be the boiler pressure. So boiler pressure, the corresponding volume and the temperature. And that we mark it to be the point A in the PV plot. And when this steam is made to pass into the steam turbine, the work is done by the steam because it contains enormous amount of thermal energy, and it has to do some work by making the blades rotate. The heat energy is being converted to mechanical energy, and since the work is done by the steam, the energy from the steam is lost and the volume pressure decreases to a point, say B. So what happens here is the system changes from one state to another state. Say at the exhaust or the condenser, before the condenser, if you need to measure the steam at a pressure, condenser pressure, say PC, and volume and temperature. Here you can say the system has been changed from system point A to point B, or from state A to state B. So the system is set to undergo a thermodynamic process. So here the process is expansion because it is being expanded. So considering this, we have 4 main varieties of processes, basic process. One is the isobaric process. Earlier I told you there are 3 main parameters: volume, pressure, and temperature. So while the system is doing some work, normally it is the routine way of keeping one parameter to be a constant. So that is what the gas laws also tells us. So isobaric process is a process where we maintain the pressure to be constant. So pressure and temperature here will be varying, whereas you maintain the volume to be constant. An isothermal process, it is a constant temperature process. Here also we maintain the temperature to be constant, whereas pressure and volume will be having a change. And isochoric process, where the volume will be held constant and pressure and temperature will change. And the 4th process is the adiabatic process, where it is similar to isolation. There will not be any heat transfer into or from or into the system. And here also we create such system. And in thermodynamics, all the reversible process which are adiabatic, they are called to be the isentropic process. We'll see that their entropy is a new derived property. So this is designated here in the form of PV diagram. So isochoric, the volume is constant, so it's a vertical line. Isobaric process, it's a horizontal line where the pressure is constant. And isothermal is a curve where the curve is governed by the law PV is equal to constant. PV is equal to nRT, so N is a constant, R is a constant. Again, temperature is a constant, so nRT is a constant. So PV is equal to C in the case of isothermal. Whereas adiabatic, you have an adiabatic index called gamma. And the value of gamma is 1.4. So that curve will be governed by PV power gamma is equal to constant, where gamma is 1.4. So here in a process, we have 2 main functions. So which really governs the process. One is the path function, other one is the process. So path here in the graph, you can see an IC engine where you have a piston and a cylinder arrangement. So initially it is at a volume of V1 and pressure of P1. So this is the initial state. And after a time of T, the processes, it has undergone a process following a path of 1 to 2, as shown in the red line. So the volume is changed to V2 and pressure is changed to P2. So here you can see from the graph, the volume is reduced and the pressure is increased to a final stage. So the process here is compression, and you can say the system is undergone a process of compression. So here the path traveled by the system is shown by the red line 1 to 2. And how we have got this path? We know 1.1, we have measured it, and 0.2 we know, but 1 to 2, how we have marked the points is, again, we have to define another one process called quasi-static process, where we consider each finite movements of the process, we consider it to be equilibrium, and we mark it every state, every point, and then we plot the curve. So here, and then we mark the path followed by a process. Whereas here, in this slide shown here, only 1 and 2 are marked. And here it is a expansion process, because initially the pressure is higher, volume is V1, and after the process has been executed, the pressure is P2 and volume is V2. There is increase in volume and decrease in pressure. So some amount of work has been done by the system, but we don't know the path traced out between 1 and 2. It may be above 1 and 2 or below 1 and 2, the point 1 and 2. There can be many n number of paths traveled by the system, but here it is not known. Only the point is there. So only 2 states are there. That we call it the exact differential or the accurate value. Pressure, temperature, they come under this category. Whereas path function, the same graph, as the system executes the change from state 1 to state 2, there are 3 different paths followed: P, Q, and R. So say the system is set to execute this process by 1 P2, the area under the PV will be lesser, because we know the work done is given by the equation pressure into change in volume. So here the area under the curve 1 path P and 2 will be lesser than the area under 1 path R and 2. And of course, it will be new. In between will be 1 path Q and 2. So normally, if such option is given, the maximum work done will be 1 path R and 2. So if it is a positive work, then if there are 3 options available, then normally we will be choosing the path of 1 path R and 2. So this is the path function, whereas in the previous slide, the property is only dependent, the system is dependent on only 2 points. It doesn't take care of the path travel. Whereas here, it is obvious that the work done or whatever may be the area under the plot, it is an proportional against whatever is plotted. Suppose instead of P and V, we plot temperature and entropy T into Ts. So T into Ts, it designates the heat. So work, heat, they come under this category. So work, heat, they are path functions, whereas the pressure, volume, temperature, they are point functions. They don't depend upon the path. And this is the thermodynamic cycle. So point, state, process, and the process including two functions. One is the path and the point, and then cycle. So if there are n number of processes executed by the thermodynamic system, and the system returns to the initial state, then the thermodynamic system is said to have executed a thermodynamic cycle. So here it shows a graph of 4 processes, 1 to 2, 2 to 3, 3, 4, and 4 to 1. In the final stage, the system returns to its initial path where it starts. And it's a PV plot. So everybody will be familiar with this law, zeroth law of thermodynamics, whatever may be the discipline we have taken. You might have studied in the 3rd semester. It's a very famous 2 marks question also, zeroth law of thermodynamics. And why the name of zeroth law is given to this here means after the first law of thermodynamics was formulated, then this law was formulated. But this law formed the basis of the thermodynamics, basis for the temperature measurement. So no other number was there. So 0 was given. So zeroth law of thermodynamics, the naming was given. So it states that if there are 3 systems, say A, B, C, and A and B, they are in thermal equilibrium with each other, and A and C, they are also in thermal equilibrium with each other separately, then we say that B is in thermal equilibrium with C. So thermal equilibrium with C. Thermal means the temperature should be constant. So this law made the base for the temperature measurement. So that is what we are doing in everyday day-to-day life of measuring the temperature for fever. So we have 3 systems: human body, the temperature measuring equipment, and the liquid which is being raised inside the measuring fluid. So once we keep the thermometer, initially at once we don't take the temperature. We leave it for few minutes until this equilibrium is achieved, and then we measure the temperature. So this is the zeroth law of thermodynamics. And this is the first law of thermodynamics. So Joule, a scientist, he made some experiments. So based on the law of conservation of energy, the base for the first law of thermodynamics was the law of conservation of energy, which really says that one form of energy is being converted into another form. Energy can neither be created nor be destroyed. So we can take the simple example of a human being where we take in food, do some work, and the energy is exhausted. And again, some form of energy is taken in, and that's what is the base. One form of energy is being converted to another form. So Joule, he did some experiment called the paddle wheel experiment, which had a container with a steerer, with the paddle arrangement, pulley arrangement, which was moved by a weight. So he did it many times, and after that he came to a conclusion. Whenever the weight is made to put on the equipment and the pulley arrangement, the steerer was moving, and the fluid inside the steerer, it became hot after some time. So after multiple experiments, he came to a conclusion that work and heat, they are mutually convertible to one another. And finally, the first law of thermodynamics was stated as work and heat are mutually convertible to each other. So here we have three definitions or three forms of energy. One is the heat, another one is the work, other one is the internal energy. So we define heat to be one form of energy, which is transferred from one body to another, whenever there is some difference in temperature. Suppose if you have a cup of hot tea available to you, tea. Initially, say it is at a higher temperature. Say after a few minutes, the tea gets cooled due to the heat transfer from the tea to the ambient temperature till the equilibrium is attained. So once equilibrium is attained, you cannot cool the tea. So it is by natural convection. And thereby you say there is some heat transfer. And that is one reason while we people like to drink tea as hot, because we feel that some energy is going inside. So that is basically given by a equation Q is equivalent to mCp into del T. So del T is the difference in temperature. So this equation, the Q will be given in terms of joules. And work. Work is again, it's a form of energy where the work is said to be done whenever there is some exchange of energy transfer from one system to another system with a change in volume. If there is no change in volume, the work transfer is zero. And again, this is derived equation, work done is equal to pressure multiplied by the difference in volume. And what is this internal energy? So heat and work, they are mutually convertible. And what is this internal energy? So we have some energy of our own by virtue of our own. And we increase our energy either by food, we add in, we eat, chemical energy, it gets converted to chemical energy, our energy increases. But initially we have some energy of our own. And in thermodynamics, U is a function of temperature. Internal energy is designated by U and it is a function of temperature. So here, converted into work by the first law of thermodynamics, you say that work and heat are mutually convertible to each other. By this process, there may be some change in the internal energy. Either the internal energy will increase or the internal energy will decrease, depending upon the process. Suppose if heat is rejected and work is done by the system, then the internal energy of the system will decrease because it has done some work. So by then the internal energy decreases. Suppose heat is added to the system, we given heat to the system. So giving in heat, the internal energy of the system increases and it is ready to do some work. And again, the same example of a boiler or a turbine we can take in. Heat is added, the internal energy increases, and then it does some work. The steam expands and the mechanical energy is being coupled to the generator and we get the electrical energy. So the three forms of energy put in together by applying the first law of thermodynamics, we get the non-flow energy equation. That is del U or du is equal to Q plus W. So which relates the heat, internal energy, and work. So all the equations, you have the energy in the form of joules. So del U, it will be mCV into dt, which will be in terms of joules, and Q is equal to mCp into del T, which will be in terms of joules. And again, work is equal to pressure into difference in volume, it will be in terms of joules. So this equation is termed to be non-flow energy equation. Now we'll apply this equation to all the process what we have seen earlier. So here, non-flow energy equation, we apply to a constant volume process. So we know by the non-flow energy equation, dQ is equal to Q plus W. But work done is 0 for a constant volume process because work done is given by pressure into difference in volume. When it is a constant volume, dV will be 0. So entire term will be 0. And thereby du is equivalent to Q. So which implies that in a non-flow energy process, and that too in a constant volume process, whatever may be the heat supplied, that will be utilized in the change of the internal energy. That means here two conditions arise. If you're going to pull out heat from the system, that means if the heat is rejected from the system, the internal energy of the system decreases. If you're going to add heat to the system, then the internal energy of the system increases. Take in the case of a boiler, you are adding heat and thereby the internal energy of the boiler will be higher. It is increasing till you stop the addition of heat. In the case of condenser, it will be the reverse process where the heat is being rejected to the atmosphere and thereby the internal energy of the condensing system will be decreasing. This is the inference based upon the first law of thermodynamics. Now we'll apply it to constant pressure process. So non-flow energy equation, when you are applying to be a constant pressure. So constant pressure will be constant. There will be some change in volume. Q will be there. And since both are having a change, du also will have a change. So the equation is du is equal to Q plus P into dV, where here the P into dV, that mechanically call it to be the flow work because there is some pressure and there is some flow of fluid or gas, whatever may be involved in the system. So there is some flow. So due to this, and this is also a form of energy, and it's called to be the flow energy or flow work. So the combination of U plus PV, you call it to be the another property called enthalpy. So it's a derived property and it is given by U plus P. The Q will be equivalent to dH. So during a constant pressure process, in a non-flow energy process, whatever may be the heat supply, dH is called to be the enthalpy, which is equal to the heat. And now we'll apply this non-flow energy equation to a constant temperature process. So constant temperature process, again, du is equal to Q plus W. This is the non-flow energy equation. For a constant temperature, T will be constant. So as said earlier, U is a function of T. Internal energy is a function of temperature. Energy will be 0, and thereby Q will be equivalent to P into D. Or you can say from this equation, for a constant temperature, the work done, whatever may be the work done, it will be utilized Suppose if you don't take in any food and do some work, at the end of the day, you'll be exhausted because whatever may be the work you do, it will be consumed from your own internal energy. So like that, if the work done will be utilized from the internal energy of the system. And this is first law of thermodynamics. When you apply it to a flow process. So non-flow process, there is no mass flow. So for a flow process, take the same example of the steam turbine separated by control volume. Taking the inlet of the steam turbine, we have the inlet of the turbine will be at a certain height. So your potential energy will come into play, and in the certain amount of steam will be entering at a velocity of C1, and therefore kinetic energy will be coming into the picture. And as we said now, U plus PV, there will be some internal energy and there will be some flow work, PV, and that is combined to be H1, enthalpy. So H1 is the enthalpy, which is equivalent to U1 plus P1 V1. It's a derived property plus the heat. It is equivalent to G into Z2. Now you apply the energy equation at the exit of the turbine. So the exit of the turbine, the outlet will be placed at a certain height. So that is the Z. And that constitutes the potential energy of 0.2. And the steam will be coming outside with a velocity of C2. Since it is a turbine, it will be the exhaust velocity, which will be lesser. And it is equivalent to C2 square by 2. So here mass is said to be 1. That's why the parameter of M is not multiplied. Plus there is some amount of work done by the turbine, which is W. So from first law of thermodynamics, the total energy entering the system is equivalent to the total energy leaving the system. The energy balance equation is written for a steam turbine or whatever may be the system. It's a general equation. So this is the steady flow energy equation. This equation is called to be the steady flow energy because while deriving this equation, while getting this form, we make some assumptions that the flow is steady, the control volume is fixed, the energy, other energies are nil, they're neglected. Only the predominant energies will be the kinetic, potential, internal energy, the flow work, and Q and W. And this is the generalized form of the energy flow equation. And this equation can be applied to any system, say boiler or nozzle or a steam turbine, whatever is needed, that parameter, that energy will be taken. If it is lesser, if one energy is lesser than the other practically, then it will be neglected. And only the main energy will be taken and the equations will be derived for each component, thermal component, and the analysis or the thermal analysis will be done using the derived equation. So of thermodynamics as we have applied to non-flow process and that too for process under non-flow and the generalized equation for a flow process. So I think time is really up. Sorry for the initial delay. There was some problem in the system. Any queries can take it up, please.
Thank you so much, madam. It was an excellent presentation. So, hopefully we will go through it with the questionnaire.
Okay, sir. Thank you.
Will
Anyone?
there be any extended session for the subject?
Sir, come again, sir.
Oh, I'm asking, will there be part 2?
Yes, I
Directly
think
will
so.
be going to
Yes, sir. There should be
Dr.
part
Mary?
2. Mary, ma'am, you need
Yes,
to.
sir. This is first law of thermodynamics completed. Of course, second law of thermodynamics followed by third law will be there. But I think we
Okay,
will have
anyway.
some after 25th or I'll take up by
Sorry?
25th. 25th, I'll be taking, sir. Shall I take it on 25th, sir?
Yes, ma'am, with pleasure you can take it, not an issue.
Okay.
Like the continuity of the subjects, again, you need to make up the system, understand with the same theory. Yes, there should be a continuity. That's right. So you can make a point that you are covering up again by 25th with a short gist of information, and then we can go ahead. Not an issue.
Yeah, okay, sir.
By
Maybe
tomorrow.
10 minutes earlier, I'll give up a review of what I've taken earlier, and then go for the other session.
Yes, ma'am. Yes, ma'am. So that would be great.
Yeah,
So,
any
Paranam,
feedback, it can also be given, sir, further improvement.
yes, people can give the feedback. Anand Kumar, sir.
Sir, it was an excellent one, sir, actually. Swapna sir, நான் வந்து ஆக்சுவலா திருப்பியும் ஒரு எத்தனை மணி சில பேர் ரெஃப்ரெஷ் பண்ண மாதிரி இருந்தது. ஸோ கண்டிப்பா இதுதான் வந்து ஆக்சுவலா பேசிக் சார். நம்ம இந்த திருமல் யூட்டிலைசேஷன் போகும்போது இந்த பேசிக் இல்லாம நம்ம கண்டிப்பா வந்து அதர் ஸ்டெப்புக்கு போக முடியாது. ஸோ இது வந்து ஒன் ஆஃப் த வெரி வெரி இம்பார்ட்டன்ட். நம்ம நம்மள இந்த ஆடிட்டுக்கு பொறுத்தவரையும் இதை பேஸ் பண்ணி தான் வந்து நம்ம திருமல் யூட்டிலிட்டி வந்து டைரக்டா போக முடியும். ஸோ மேடம் நல்லாவே எடுத்திருந்தாங்க. ஸோ நல்லா இருந்துச்சு. ஸோ சொன்ன மாதிரி அடுத்த ஸ்டெப் போகும்போது கொஞ்சம் இந்த ப்ராப்ளம்ஸ் எல்லாம் சால்வ் பண்ணும்போது எல்லாருக்குமே இன்னும் கொஞ்சம் ரொம்ப யூஸ்ஃபுல்லா இருக்கும் சார்.
Yeah, fine, sir.
குட். பரந்தமன் சார், நீங்க சொல்லுங்க சார். அவங்க பரந்தமன் சார். சார் பரந்தமன் சார், வேற யாராவது ஃபீட்பேக் கொடுத்தீங்கன்னா அதுக்கேற்ற மாதிரி மேடம் வந்து வேற அடிஷ்னலா என்ன சொல்லணும் அப்படின்றதெல்லாம் கேக்குறாங்க. ஸோ எல்லாம் சரியா இருந்தது அப்படின்னா நம்ம வந்து இன்றைய தினத்தை க்ளோஸ் பண்ணிப்போம். நாளைய தினத்துக்கான கிளாஸ் வந்து என்னன்னு பார்க்கலாம். எஸ் சார். ரொம்ப நேரமா டிராவல் பண்றீங்க போல இருக்குங்க சார். இன்னும் வீடு வந்து சேரலையா?
Nice presentation.
Thank you, sir. Thank you.
உண்மையில நீங்க என்ஸ்டி பேஸ்ல எடுத்தது இங்க நல்லா இருக்கு கிளாஸ். ஆன்லைன் ப்ரோக்ராம் நல்லா எக்ஸலண்டா இருக்கு. ரெகுலர் ப்ரோக்ராம் விட ஆன்லைன் ப்ரோக்ராம்ல எல்லா சீனியர்ஸ் பார்த்துட்டு நீங்க ரொம்ப யோசிப்பீங்க. இங்க அதெல்லாம் எல்லாம் அழகா பேசுவீங்க. ஹேட்ஸ் ஆஃப் டு யூ.
Yeah, thank you, sir.
சார் நாளைய கிளாஸ் யாருங்க சார்?
பண்ணிக்கலாமா?
நாளைய கிளாஸ் நீங்க எடுக்கிறீங்க.
ஆமா, அந்த ஃபினான்ஷியல் கொஞ்சம் இருக்கிறதையும் க்ளோஸ் பண்ண சொன்னீங்க. அதனால கொஞ்சம் ஒரு ஷார்ட்டா போட்டுட்டு போயிடலாம்னு நினைக்கிறேன். அதுக்குள்ள
அடுத்த நாளுக்கு உரியவங்களாவது இன்னைக்கு கன்ஃபர்மேஷன் பண்ணுங்க. வேற யாராவது இருக்கீங்களா? டைட்டானிக் கப்பல்ல கூப்பிடுற மாதிரி கூப்பிட வேண்டியதா இருக்கு. யாராவது இருக்கீங்களா? சரி, எல்லாருமே இருக்காங்க போல இருக்கு. மதிப்போட இது பண்ணிப்போம். நாளைய தினம் திரும்ப சந்திப்போம். அதுக்கான இதோட ரொம்ப சந்தோஷமா இருக்கு. ஸோ இந்த லிங்க் வந்து இன்னைக்கு லைவ் லிங்க் வேணா ஷேர் பண்ணிக்கலாம். ஸோ மற்றவர்கள் கொஞ்சம் இதுக்கான தீர்வுகளோட பயணிக்கிறதுக்கு லைவா இருக்கக்கூடிய ஒரு விஷயத்தையும் இதையும் கலந்து கூட நீங்க சொல்லலாமா? ஏன்னா எனக்கு என்னென்ன நீங்க சொல்லிட்டு இருக்கும்போது நிறைய விஷயம் வந்து பாய்லர் இது சம்பந்தப்பட்டது சொல்லும்போது, ஸோ இந்த இது வந்து இப்படி ஆப்ரேஷனல் நடக்கிறதுக்கான காரணம் என்னன்னு கேள்விகளாக கேட்கும்போது இன்னும் கொஞ்சம் இதுவாகவே இருக்கும். ப்ராக்டிக்கல் எக்ஸ்பீரியன்ஸை கொஞ்சம் ஜெல் ஆகிறதுக்கு. எப்போதுமே தெர்மோடைனமிக்ஸ் வந்து சூப்பரான சப்ஜெக்ட், லைஃபுக்கு தேவையானது தெர்மோடைனமிக்ஸ் கூட. ஸோ அதை கொஞ்சம் நல்லா தெளிவாகவே சொன்னீங்க. நம்ம வந்து எந்தெந்த இடத்துல எதெல்லாம் பயணிக்க போறோம் அப்படின்றதையும் சேர்த்து சொல்லும் போது இன்னும் சிறப்பாக இருக்கும். நான் கொஸ்டின் வைஸ் சொல்லலை, எந்த இடத்துல இது வந்து ஏன் இப்படி இயங்குது அப்படின்னு நம்ம அந்த கேள்வியை கேட்கும்போது அந்த லா ஆஃப் தெர்மோடைனமிக்ஸ் இம்ப்ளிமெண்டேஷனோட பார்ட்டும் நல்லாவே புரியும் அப்படின்றதுக்காக நான் சொன்னேன் நானு. ஸோ அதையும் கொஞ்சம் கலந்து நீங்க சொல்லும் போது இன்னும் சிறப்பா இருக்கும். நான் என்னோட பர்சனல் இதை சொல்றேன் நானு. சிறப்பா இருந்ததுன்றத நான் முன்னாடியே சொல்லிட்டேன். பட் அடிஷனலா ஏன்னா இப்ப தெர்மோடைனமிக்ஸ் வந்து படிக்கிறவங்களுக்கு மெக்கானிக்கல் ஆமா, மெக்கானிக்கல் இன்ஜினியருக்கு இது யதார்த்தமான ஒரு செய்தியா இருக்கும். பட் ஒரு ஐடி இன்ஜினியருக்கே புரியணும் அப்படின்ற அளவுக்கு நான் சொல்றேன் நானு. ஸோ அது வந்து என்னன்னு பேசிக்கா புரியாது. அது வந்து ஏன் குக்கர் வந்து மலை பிரதேசத்துல இருக்கிறவங்களுக்கும் இங்க நார்மலா ஒரு லேண்ட்ல இருக்கிறவங்களுக்கும் எது சீக்கிரமா வெந்து தனியும் அப்படின்னு நம்ம கேட்டோம்னா அந்த கேள்விக்கு பதில் சிந்திக்கிற மாதிரி இருக்கும் அப்படின்றது ஒரு எக்ஸாம்பிள். ஸோ அந்த மாதிரி ஒரு பாயிண்ட்டை வந்து கொஞ்சம் தெளிவுபடுத்திட்டு அதை சொல்லும் போது வில் கெட் மோர் ஆன்சர் ஆஃப் சச் திங்ஸ்.
கண்டிப்பா சார்.
நம்ம அது தொடர்ந்து பயணிப்போமா? மகிழ்ச்சி. ஸோ நேரம் கடந்து விட்டதனால் வேற எதுவும் கேள்விகள் இல்லை என்பதனால் நம்ம இத்துடன் முடித்துக் கொள்வோம். நன்றிகளுடன் நாளை தொடங்கலாம். மகிழ்ச்சி. நன்றி.
தேங்க்யூ சார். நன்றி.